be able to hear me and you should be able to see my screen. Great. Thanks for the thumbs up. So if you can hear me and you can see my screen, we are good to go. So all what you need now is make sure your book is open and you will take some notes. But before we begin, do we have any question in advance? So the paper I shared in the group, I shared the 2019 paper. I couldn't find the 2022 paper. 2020, they wrote online, in 2021, it was online, but I think I shared those papers in the groups. So before we kickstart, do we have any questions, suggestions, compliments, critiques, anything? Okay, someone is saying in the group, please share the papers again. Let me quickly scroll up and re-forward them. So let me forward them again. The same group, the first year SETMind group. So if you are there, you should be able to see the papers which came in now and the one which I'm mentioning. So I think how we are going to address the different concepts with people is that we are going to work on questions. And as we are working on questions, then we will say, remember this. That's how we are going to do revision. So we are not going to try and squeeze the entire course in this session. But when we do a question, I will say, this is what you need to know. And if you remember, this is how you do this for you to be able to answer this question. Are we okay? Okay, that's how we are going to work. So the questions are the ones which are going to guide our revision. So if you can all see my screen and I'm audible, loud and clear, then we can, and now I assume you can see my screen. So one favor I need from your side is that when you can see a question on the chat section, so when I'm here, I cannot see what's going on the chat section. So those who can unmute themselves, please give me the question which is on the chat section, because some people are in libraries or they're in places where they cannot unmute themselves. So if you see a question and you can unmute yourself, please give it a shot. So read the question out. Feel free to disturb me.
Sir, we are not able to access the chat section.
Okay, so there's Mr. Ferrete in the meeting. I think he's going to get that sorted. So why are you not able to access the chat section? Because I can see it started. Okay, so Mr. Ferrete will fix that part. So us in the meantime, let's just work, and then as soon as it is resolved, you'll be able to see what's on the chat section. Okay, so let's jump straight to the business of the day. Okay, so let's look at 2019, that paper. So I'm looking at something in the group. So we have Jerome September in the group. Was under the impression that it's the dean. Impressive. So let's look at 2019 and let's see how we can unpack that. So we have the dean of students in the group. Impressive. So we will look at both calculus and algebra. So let's start with the easiest. So we all know calculus is relatively easy compared to algebra. Okay, is there a way to join using my PC? I don't have Teams on my phone. So that person, one thing you can do, open your WhatsApp on your computer, and then you can click the link. Then you join using the web. So let's look at calculus 2019. And let's see what we need to take away from there. So if you check those papers, there's one which you should be able to find there for calculus. So let's quickly go to question 1 of calculus 2019. So what's going on is there we are given wait a sec. Let's open the paper. So it's gonna be that. So we are given that sketch. So please, if you can open the sketch, but I'll try to redraw.
Ah.
Yes. We might find ourselves hearing things we're not supposed to hear. So let's get our f of x. So you were given x plus 4, and they're saying x must be between 2, negative 2, but excluded, but including negative 4. And the second equation which we're given there is that we have 3, and that 3 is the function for an x value of negative 2. And then we're also given negative x, of which our function is negative x for x is between 0 included and negative 2 excluded. And then the last thing we were given was 2. They gave us that our x must be greater than 0. So the question for question 1, they were saying sketch this function or sketch f of x. Calculus 2019. This was the April test. So pretty much like what you're gonna be writing. So let's quickly see how we can sketch this, good people. So let's put our Cartesian plane down and see where we should start. Let's make it at 24. Okay, let me quickly make a scale. Let's say we have 1 here, 2 here, we have 3 here, and then we have 4 here. And then here, let's put negative 1, negative 2, negative 3, negative 4. And then maybe here, let's put 1, let's put 2, let's put 3, and let's put 4 there. Then maybe here, let's put negative 1, and negative 2, and maybe negative 3 there. So we are asked to sketch this. So you should be aware that for calculus, the easy chances are going to be a question on sketching. So let's start with the easiest function, right? So the easiest one is this one here. So they are saying our y is 3. So let's try and interpret that function. It is saying our y is 3 at x is negative 2. Okay. So which means we need to go at y is 3 and put a line there, and then this should correspond with an x value of negative 2. So this is our point there, the red one. So that's -1 problem. Okay, maybe we can leave those dotted lines here. So that's done with that function. So let's look at the easy function, the other one, which is very easy to plot. Let's make it green. So this one here, all what they're saying there is that our y is equal to 2 for x values which are greater than 0. So here's our 2, y is 2. But if you look at the x value, it is not included. So meaning x is 0 is not included. So meaning we should go there at x is 0, at y is 2, we should put a circle because x is 0 is not included, okay? So we go there, we put a circle, and we know all x values which are greater than 0, they go in this direction. So that's why our line will go to the right. Do we have any questions on this? Okay, let's carry on and see what we obtain, right? So the easy one, the next one is this one here. So that one they are saying y is equal to negative x. So as we know, y is negative x is a straight line. We know it. Since it's negative x, it should be a function which is in this direction like this. So we know that. They're saying y is negative x for x values which are between 0, 0 included, and -2, but -2 is excluded. So what we know is that y is x, y is negative x looks like this. So it goes, the graph which goes like this. But they are saying the x values are between 0 and -2. So x is 0 is here. We start here, and then we will end at x is -2, which is this. But at x is -2, we exclude. So we draw a line like this. And there you go. That's your yellow function. Do we have any question on this? Okay, there's no question. Let's go for the last one. Let's see what we obtain. So which color? Pink. So let's go for this. So for this one, all what they are saying is that our y is x plus 4. Okay. And this function will be x plus 4 for x values which are between -2, but -2 is excluded, and -4, which is included. Okay. So we all know how the function x plus 4 looks like. So when you do x plus 4 as a plot, you will find out that the x-intercept is at x is -4. And then when you plot that graph, when you put, let's say, x is -3, you get a corresponding y value of 1. And then when you put x is -2, you get a corresponding value of 2. So the graph goes here. And then it's just a straight line. So this is not according to scale. My apologies on that end. So this should just go straight like this. So this is how our graph should look like. Do we have any questions? Where is that line? Yes. So this is our full sketch. Do we have anyone who has a question?
Hi, sir.
Yes.
Can I please ask, at -2 and 2, isn't the function excluded there?
At -2, let me see, the pink one. Yes, it is excluded. Thank you. So let's quickly rectify that mistake. So be wary of these kind of things. You can easily make a mistake. So it is excluded at -2. So here we should just come there, and it's just going to be a circle. So it is excluded. Thank you. So this is our complete function. Whoever is marking is going to be really happy with us. We know what we are doing. So one thing which I need to mention here is that this is not drawn according to scale. So in B, I don't have a graph paper. So lucky enough, you'll be having a graph paper, so you won't have this excuse. Not drawn according to scale. To scale. So we are done with the question. Now, what we need to do now is to answer the other questions. So do we have anyone who has a question regarding this? What we have done? Anyone? Okay, if there's no one, let's go for B. So this was question 1A. They needed us to sketch that function. So let's go for B. I'll zoom in and zoom out when I deem necessary. So let's look at B. So for B, they are saying find the left and right limits at x is -2 and at x is 0. Okay, so let me say find the left and right limits at x is 2, it's -2. X is -2 and x is 0. And then most importantly, they are saying classify those discontinuities. So we should all understand what that means, because Monday they say classify the discontinuity, and you run black, it's going to be a problem. Classify the discontinuity. So let's take this to the next page. And then I'll copy the graph again and we start analyzing this. So let's quickly get the graph. Start doing some magic here. Okay, there we go. We have our graph and we have our question there. So they're saying we need to find the left and right limit at x is -2. So let's think about the right limit at x is -2. So let's say right limit at x is -2. So all what this means is we'll approach -2 from the right. Okay, we'll approach x is -2 from the right, meaning we're driving our own car. We choose this color here. So meaning if we are driving a car, we'll be approaching x is -2 from this direction, which is the right. Okay, that color is too light, you cannot see it. Let's take this one. So we are approaching x is -2 from the right. That's what we mean. And when we're approaching x is -2, our concern is what is the y value? That's our concern. We are approaching x is -2 from the right, and our concern is what is the y value which we are approaching. So do we have anyone who has an idea? What the answer should be?
Two, sir.
Okay, why 2?
I think it's 2.
So the limit of, so we have our f of x and we are approaching. So one thing I need you to be careful of, we'll say x, we are approaching -2. So when we're coming from the right, we will put a plus here. That means we are coming from the right. Okay. So what is the answer here? Why are you guys saying it is 2? So we said we are approaching x is 2, but we are looking at the y values up there. As we approach x is 2, what y value are we approaching up there? So why are you saying we are approaching 2? Anyone who has the answer?
It's because like
It's because of what? Can you repeat?
oh, what I was saying is that like when we are moving from the right like towards 2, we are concerned with what is the y value, and in this case, our y value is 2 from the right. Like
Yes,
it's like I think yeah.
yes, because what's going on is when we come from the right, the next function we are going to find is this function here. So we'll use that function, we go up, and when we get to 2, -2, we check what y value do we have there, and the y value which we have is 2 there. So that's why we are approaching 2. And the question is, what kind of a discontinuity is this? So this we will say it is a removable. Why removable? Anyone who has an idea why we are saying it's removable?
Because it's a jump continuity, I think.
It is because at x is 3 is -2. We have a point which is included. Can you see? At 3, we have a point that is included. It's because at x is 2, -2, we have a point which is included. The point we are referring to is just this point. It's shaded. So when it's shaded, it is not excluded. So that's the reason why we have a removable discontinuities, because we have a point which is included, which means there is continuity at that point. So if this red point here was circular excluded, this was not going to be a removable discontinuity. Okay. So let's look at the left limit at x is 2.
Sir, please repeat the removable part.
Yes. So I'm saying at x is -2, which is here, this is our x is -2. When we look at the corresponding y value, it is 2 there when we approach from the left. But we are going to say that discontinuity is removable because we have a point which is included. So you see that there's at x is -2, we also have a function which is y is 3. So that point which is included is what removes, is what makes this discontinuity to be removable. It's because we have a point that is included at x is -2, which is this red point here. It's the one which is included. If it was circular, this would just be a jump. If it was circular and not shaded. Does this answer the question?
Yes, sir.
Okay, so let's look at the left limit at x is -2. So when we say
Sir,
the left limit, yes.
can I ask if that point with -2 and 2 was shaded, would we still say it's removable?
If it was shaded, and then there was another
would we say,
point.
yeah, let's say -2 and 2 it's shaded, then also that point at -2 and 3.
Yes, and then on top of the -2 and 2, the graph which comes from the left, would you want it to be excluded or also shaded? Because at -2 and 2, we have two graphs which are at that point. It's the x plus 4 and the x is negative and the y is -x.
Yeah, let's say that point is shaded.
So you wouldn't have you would have a jump there.
Oh, okay.
Okay, so let's look at the left. Let's see when we come from the left what we observe. Okay, so when we come from the left towards x is -2, guess what? The graph which is helping us to come from the left is this one. So we can see that when we are approaching x is -2, we are, so I'll say the limit as x approaches -2, but since I'm approaching from the left, I'm going to put minus there as the power of that 2. Then we'll put f of x. So we can see that we are still approaching -2, but because at x is -2, we have that point which is at -2 and 3, which is included, then the discontinuity will say it is removable. Continuity. And the reason is still the same. At x is -2, we have point that is included. It's the point which is at 3 is included. Any questions here? So that's done. Do you have any question regarding the answers too?
So
Yes.
So what's the difference between a jump discontinuity and removable discontinuity?
So jump discontinuity, it means at that point there is, let's see. Okay, let's do the next one and then you'll see. Let's come to the next one. Let me copy the sketch and see what we have. Let's answer
Why
the
is f of x equals to -2 and not +2?
-2, it is +2. Silly mistake there. Thank you. Okay, so let's look at the limit as we approach 0. So let's say the limit, or let's say the right. At x is 0. So this you would write as the limit of x as it approaches 0. We put a plus there, meaning we're coming from the right, of f of x is equal to. So let's see what's going on here. So we're coming from this side. And when we are coming from this side, the function which allows us, which we easily catch first, is this green function. So we'll use it to come towards x is 0. Okay, so then the question here is, what value can we say we are approaching as we approach 0 from the positive side? So I'll need some reasoning here. Someone please unmute and give it a shot. There's no right or wrong answer.
It's 2.
I think the answer is 2.
Why are we taking 2?
I think because the function at that point, at 0 is equals to 2, and we want a point, we want like a value of y in which we can get as the function decreases to 0.
Yes. So the value which we are approaching here is exactly that. The function which we catch when we come from this side is exactly the green function. And if you can see, the more we go to 0, the more we approach 2. So our answer is 2. And now the question is, what kind of discontinuity is this? So we need to wrap our heads.
Jump.
Okay, why is it a, okay, it's, well, the reason why it's a jump is apparent. Yes, the question, Do we have someone who's asking a question?
Yes.
Yes, what's the question?
Is it a jump discontinuity because the point is excluded?
Okay, so the reason why they are saying it's a jump is just literal. So let's see. So we obviously have this here. So we have 1 point here, and then we have another one there. So it's apparent why it's a jump. But the question is, at x is 0, we have the point included. So why are we not saying this is removable?
Hi, sir.
Yes.
I think it's because the limit from the right is not equal to the limit from the left, because for a continuous graph, the limit from the right has to be equal to the limit from the left. But
Yep.
since that's not true, it's a discontinuous.
Yep. So
But
it's a jump. Yes.
it's also not a removable disk because the value of c, the value of x lies within the domain of this function.
Exactly. So one thing, thanks for your input. We really appreciate it. One thing you should understand is we are not looking at x is 0. So what we are saying here, this is approaching. So you guys should be careful of how you look at these graphs. So we are approaching x is 0 from this side. We don't get at x is 0. We are approaching it. So as we approach x is 0, the domain, the function which we catch is this function here, which if you remember, it is at y is 2 and x is greater than 0. So the more we get closer to x is 0, but we don't get at x is 0, we see a 2. So that's why we are not going to say it's even removable or whatnot. So you should be careful that the limit does not mean equal to. We are not looking at the function value at x is 0, but we are looking at the value of the function as we approach 0 from the right-hand side. So let's look at the limit or the left limit and see what we can conclude of it. So here we're just approaching x from the negative side. So let's quickly see, we're approaching x is 0 from the negative side. So let's approach x is 0 from the left and see what we can conclude there. So let's see, let's use this color. So we are coming from this side and we're approaching x is 0. So we can see that as we are approaching x is 0, this is the function which is assisting us to go towards x is 0. It's the function which is defined around there. So as we approach x is 0, what y value are we approaching looking at that function?
0.
Okay, limit as x approaches 0. We must put a negative there at the top to indicate we are coming from which direction. And we can see we're approaching a 0 there. And what can we say about the discontinuity? Anyone come through for us?
It's continuous.
It's continuous.
It's continuous.
Mm-hmm. Okay, because at x is 0, we have it included there. So what can we conclude? So you guys are saying at that point it is continuous. When you approach from the left, you see a continuous, well, a point of continuity.
Removable continuous.
Okay, let's hear what others are saying. So do we have anyone else who's thinking otherwise about this question?
I think it's jump discontinuity.
Why?
It's a jump discontinuity.
So why are we picking a jump?
Then because the limit from the left and the limit of the right are not equal.
Okay, let's note that down. And then what is someone else saying?
I think it's a jump.
So can we first agree that there is a point of discontinuity at x is 0?
Yes, sir.
Yes. So now the question is, what can we say? We know that obviously it's definitely not continuous. That we need to agree. So not continuous. So for being able to spot this, you would be able to get not continuous. Okay, so it is not continuous because how do we explain this? Let's see. I can't redraw this sketch. Sorry.
Can we say that it's discontinuous because when you're approaching from the right and from the left, you get two different values?
Yes, because so one thing you need to remember, guys, is that for a function to be continuous, let me say for continuity, so you shouldn't make this mistake. If we have a function and we take the limit, we approach a from the right-hand side, and we have the limit also, and we approach a from the left-hand side. These answers must be equal for continuity. So if they are not equal, automatically the function of yours is not continuous. So that's one thing you should be aware of. Already we saw that when we approach 0 from the left, we get a 2. When we approach from the right, we are going towards a 0. So 0 and 2 are not equal. So automatically we can conclude they are not equal, that the function is not continuous. Now the question is it a jump or not? The person who asked why are you answered?
Yes, sir.
Okay, great. So now the question is this a jump or not? So this you need to note. Please, at least even if in a question you fail to answer it, at least you should be able to tell, is it continuous or not? So is it a jump or not? Can we see a jump there?
Yeah, it's a jump.
Okay, great. So we can tick that. And then there you go. Those are your answers for that question. So one thing I need you to take away, at least from what we did here, is that please note this down. Okay. You shouldn't have problems telling if a function is continuous or not continuous.
Sir,
Yes.
sir, can you please repeat again how we got f at x equal to 0?
So we said now we are approaching x is 0 from the left-hand side. Okay. And when we approach from the left-hand side, the function which will help us to go closer to 0 is the one which is sliding towards 0. And we can see that as we get closer to x is 0, the y value also points to 0. So that's why we said the limit as we approach from the negative side towards 0 is 0. Does this answer the question?
Sure.
Okay, great. So let's quickly jump into question 2 if we are all set with question 1.
So,
Yes.
can you please explain the difference between jump and removable discontinuity?
So let's say actually a removable discontinuity can be a jump. So, but immediately when we have an included point, we can then, come this side. Let me quickly redraw the graph just here at 0. So can you please repeat your question?
Can you please explain the difference between jump and removable discontinuity?
Okay, let's quickly see our sketch here. Let me copy it again. My apologies. Okay, so for number 1, the one where we're approaching x is -2 from the left and the right, did you first understand why did we say it is removable? Let's think about that first.
Yes, I did understand there. My only question is, we have a point at 0 where it is included. So why are we not saying it's removable, but it's a jump? Because we also have a point at 0, which is 2, which is not included.
Okay, so let's see. At 0, we also have a point which is included. But remember something, that we are not, let's say this. Please repeat your question again, because I'm trying to think of a best way to answer your question. Please repeat. You were saying at 0, let me highlight as you speak. Please repeat.
What's the difference between removable discontinuity and jump discontinuity, when we have a point in both cases where it is included at that point, at 0 and at -2?
Okay, so here's what we need to be aware of. We said when we are approaching this side, so we are not going straight to so we cannot put removable here, because when we come from the left, we do not have a point of discontinuity at x is 0. So remember that this here is that x is greater than 0. So let me repeat what I'm saying. So remember that we are approaching from the left. And when we approach from the left, this point here is applicable for x is greater than that. So when we approach from the left, at least at 0 minus, we do not have that point as we approach that included. I don't know if that makes sense.
I understand, it's okay.
Okay, no problem. Let me wrap my head around as we proceed. And then if I think of a better way to put that, I think I'd rather put it in writing and then we read it together and see if it makes sense. So let's quickly jump to question 2 and see what is expected of us there. So question 2, you are given f of x is x squared plus 1. So this graph should be extremely easy for one to plot. And the question which was given there is that we need to find A. We need to write down the restriction for the domain of f so that the inverse is a 1-to-1. So you guys should remember what is a 1-to-1 function in words. Let me try and plot that while we wait for someone to tell us what is a 1-to-1 function.
One x value plots to one y value.
Okay, great. One x value for every one y value. So it's 1 for 1. It is never 1 for 2 or 2 for 1. Things which happen on the modern day. So let's quickly see here. So our domain here, let's look at f of x, which is our parabola. So someone please give me the domain of f of x, that cubic function. Domain, remember, it's the possible x values.
X is the element of real numbers.
Okay, so we can alternatively, let's say, put negative infinity to positive infinity. It works, isn't it?
Yes, sir.
Okay, great. Now let's look at the range. Someone please give me the range of this function.
1 to positive infinity, I think.
So we have 1 there. So it is 1 included until positive infinity, but we'll put that there. So one thing you should be aware of is if you are giving f of x, the inverse actually looks like this when you draw it. If you remember from high school, you just tilt the graph on the x-axis, and this is still a 1 here. So if we didn't cut the part which was below this, it would be a what graph? When you draw the vertical line test, it would intersect at 2 points, which is not what we want. So can anyone state the vertical line test? What is it saying? Because when you were drawing your graph, the inverse is supposed to look like this, but now they are saying you should restrict the domain and the range such that it is a 1-to-1 function. So can someone please remind us of the vertical line test? What is going on with the vertical line test? Anyone? Can anyone remind us?
The vertical line test.
Okay, you can go.
The vertical line test is only supposed to touch the graph once, so it can be a function. Once it touches the graph more than once, then it is no longer a function.
Exactly. So we can see that when you were drawing the inverse, it was going to be like this typically from your high school thing. So we need to cut off this part here to make sure that we only touch the graph at 1 point, which is up there. So now let's look at the restrictions. So let's look at the inverse. The inverse of f of x, what is the domain?
The domain of the inverse will take the range of the
The domain is 1 to infinity.
Okay, great. So the graph can have x values starting from 1 up to a very big number, which we will call infinity. Great. And then let's look at the range. Range, it's the y values. So what can we say?
Y should be greater than 0.
Okay, but is the y is equal to 0 included?
Okay.
It's a question, is it included or it's excluded? Why can y be 0 for the inverse?
Yes, it can be 0.
Yep, so that means for the range, what do I need to write here?
Y is greater than or equal to 0.
So I can write 0 and positive infinity. So do not be emotional about how you write this, because someone else for the domain would have said x must just be greater than or equal to 1. Someone could have said y must be greater or equal to 0. Here, someone else could have said y must be greater than or equal to 1. And then here, someone could have said x is an element of the reals. So either notation, just use the notation which you understand, but at the end of the day, they all mean the same thing. Right. But here's what we need to be careful of, is that when we, this here, so I'll need to highlight this. This is a typical mistake which you can, okay, before I even highlight that, can anyone spot a mistake here? If there is even a mistake. That's if there is a mistake even. Let me zoom out a bit.
Isn't the range supposed to be y is an element of real numbers?
Yeah, that's what I thought too.
For what? Are we looking at the f of x or its inverse? F of x.
For the
So
inverse.
okay, so why for f of x cannot be an element of real numbers, good people? Because look, it starts, the only possible y values which we can have are y values starting from 1 going up the range. So that's why we have 1 up to infinity. So that's not really up for questioning. The x values are the ones which are an element of real numbers, because we can take any x value in this direction and any y value in that direction. So that is also not up for questioning. So let's look at the inverse. Is our answer okay? Inverse, yeah. Excellent. Yeah. Is our answer okay? Yeah. Okay. Yes, our answer is okay, good people. It's not a trick question. But you should have confidence in what you write. So someone should not be like, how did you get this answer? And then you start figuring, or you start thinking, where did I go wrong? So our answer is okay. So let's quickly jump into question 3 and see. So you will definitely have a question where you need to derive from first principles. So we should all know how to do that. So yes.
Can I ask?
You can ask.
When we're talking about functions and inverses, isn't that the domain interchanges between the original function and the inverse?
I understand it too.
It does. It does. Okay. Before I answer you, please, guys, check your mics. Some of you are muted. You are not muted, and you might make us to hear things we are not supposed to hear. So please check your mic before we hear things we are not supposed to hear. So what you were saying is that when you have a function f of x, its inverse will have the domain and the range will flip. So which means for the inverse, the domain will be the range will be the domain. Is that what you are saying?
Yes, sir.
Yes. So you are right only if, that would be true only if we didn't cut off this graph here. Because we wanted to make this a function, meaning when we do the vertical line test, we needed that line to cut the function at one point. So if they didn't give us that restriction, this would have been, what you are saying would have been probably true. It would have been true, not probably. But now the restriction here was
Sorry, sir, you are muted.
Can you hear me?
Yes, sir. You will
Yes, we can.
repeat.
Okay, so I'm
Yes.
saying the reason why we cannot flip the range and the domain for the inverse is because, remember, we had to cut off this part here. That part there, we had to cut it off because we needed this to be a function. And in order for it to be a function, it must pass the vertical line test. Does it make sense?
Yeah, it makes sense.
Yes. So if they didn't give us the restriction of making sure that the function is a one-to-one or the inverse is a one-to-one, we would have just take the domain, made it the range, take the range, make it the domain. So you should be careful, not be too excited and do that. If they restrict you, look at the restriction carefully and say, if it's a one-to-one function, for every x value, there must be a unique y value. So which means I must cut off this other part, which makes the second intersection the vertical line test. So let's look at question 3 and see what we are supposed to do there. So for question 3, is there someone who's asking a question?
Did we answer the question for question 2?
For question 2, yes, we did. So for, let me see, right suitable restrictions for F, and hence find the domain. So we did find those domains. So all what we need to do is to find the function, the inverse. So this falls under A. And then this will fall under B. And then the function which we're given was x squared plus 1. So for us to find the inverse, we interchange the x and the y. So meaning where there's y, you put x, and where there's x, you put y. So we are now solving for y. We'll have x minus 1. This is y squared. Then you take the square root because we are looking for y. We have 1 minus x, and this is the inverse function. So my apologies there. We needed that function and then also its domain and its range. Did we answer the question?
I'm talking about a question 2A.
So question 2A, let me see. What would be the stable restriction on the domain of F such that this is a 1-to-1? Okay, so let's quickly come here and look carefully. So this line here will behave like a mirror. So which means if we are taking this function here, it must have come from this part here. So essentially, if we are cutting that bottom part here, even this one is supposed to be, it is supposed to be out. So which then changes the domain, because I didn't see carefully that they were saying we should restrict even that function for us to ensure, because if we take this part, this line is supposed to act as a mirror, so it should reflect what is on the other side. So this means our domain, can you see that it changes if we do that? So our x will now start at 0. So our x will just be greater or equal to 0. That will be our domain. Okay, let me pause and wait for anyone to pose a question. My apologies, I didn't read that as I should have. Any questions?
What you just said, yes.
Can you please ask?
I was saying, I missed the part where you're saying that you are restricting the original graph.
Yeah. So can you see that they are saying write a suitable restriction on the domain of F? So number one, they need us to restrict F. And if you restrict F, you automatically restrict the inverse. Does it make sense? So you were supposed to draw the original graph, draw the inverse, but then put these restrictions. Are we following? Do we have anyone who's not following? Okay, I'm gonna take the silence as we understand. So this will not start making sense after the session, please. So that's why I'm giving you room to make me to stop and ask what's going on. So while we wait for anyone to ask, let's quickly go to question 3. So you cannot enter Monday's exam, not exam, but test, not knowing how to derive using first principles. So this is question 3. And they're saying we should find dy dx. And our y is given as 1 over x squared plus 1. So someone please give me what f dash is. It is the limit of what?
It is the limit of
Is x tends to 0.
As x tends to 0 of what? Anyone? Because they will definitely say first principles. At least you should know the equation, good people. So please unmute and give me that equation, because that's where you start.
Isn't
Yes.
it delta and then
It's delta x
0 is equals to f of x plus delta x minus f of x divided by delta x.
Okay, so you're saying f of x plus delta x. Someone was using this one, minus f of x divided by delta x. So let's use h because I'm using h here. It's still the same. Okay. So plus h. Yes.
Can you please change where it says limit x approaches 0?
So now it's supposed to be what if we use the h?
H is 8 approaches.
And then what do we divide by?
Mm.
Divide by h. So this is what is going on. So let's quickly see for this problem what we can find. So our f of x is given as 1 over x squared plus 1. So what I do usually, I find my f of x plus h, which is 1 over Do we all agree that this is f of x plus h?
Yeah.
Okay, cool.
Yes,
Now we can go up there and substitute this. So what I recommend most of the time is work out your f of x plus h separately in case it looks complex. And then now you can go and plug in. So please check your mic. Look at your mic. You might be the one who's speaking, unless you were intending to speak. Our f of x, we know it is 1 over x squared plus 1. And all of this is divided by h. So let's deal with the numerator. It looks a bit complex, so let's deal with it and see what we obtain. Deal with the numerator. So we can make a common denominator for the numerator the common denominator is going to be x squared plus 2hx plus h squared plus 1 times x squared plus 1. That's the common denominator which we make. And then you should know fractions. If we are trying to make that, we should have x squared plus 1 here, then minus x squared plus 2hx plus h squared plus 1, close brackets. Do we have any questions here? Anyone who sees or who doesn't see how we got here? Okay, let's start cancelling. So the x squared and the x squared will cancel. The 1 and the 1 will cancel. So that numerator there, which appears to look complex, it will end up being negative 2hx minus h squared divided by, we have x squared plus 2hx plus h squared plus 1 times x squared plus 1. So we can now go and substitute back our numerator on that expression, which is f dash of x is equal to the limit as h approaches 0. Our numerator is negative 2hx plus minus h squared divided by x squared plus 2hx, let's zoom in, plus h squared plus 1 times x squared plus 1. And this, if you remember, it was divided by h. So that h of ours we can write as multiplied by 1 over h. So 2 divided by 3 is the same as 3 multiplied by 1 over 2. Okay, so we see that we can actually cancel things out here when we factor out some h there. So we have negative 2x minus h. I need the limit. So once you forget the limit, if you get someone who's really emotional when marking, you can easily lose marks. So we factor that out, and then we have x squared plus 2hx plus h squared plus 1 times x squared plus 1 times 1 over h. So things cancel out nicely here. So we have this h cancelling with that h. And then now what we have is f prime of x is the limit as h approaches 0 of negative 2x minus h divided by x squared plus 2hx.
I'm not
Yes?
sure if it's my connection, but we can't see what you're writing after the second step, after you wrote D with the numerator.
Yeah, same.
Okay, so you all can see what I wrote.
Yes.
Yes, sir.
No, I can't see.
Yes, so we can't see.
So what can you see on my screen now?
F of x is equal to
Before you factor the denominator.
Okay, so let's quickly do this here.
Yeah.
What can you see now?
We can see someone.
Who is someone?
Monly. Switch off your camera,
Siyabamba
bro.
le phone.
What's going on now?
So we can see that you cancelled out the H's.
Okay, can you now see my screen?
Yes, sir.
What can you see?
Sihle.
Sihle.
Okay.
Sir, can you please explain the steps that came after multiplying by 1 over h? Like, why did we multiply by that?
Okay, so I said that 3 divided by 2 is the same as 3 multiplying by 1 over 2, isn't it? So all of this here was divided by h. So now instead of putting the h here, it becomes plus that I can multiply by 1 over h, but it has the same effect. You understand?
Oh, yeah, sure.
The same way this is the case. That's
So,
all what
sir,
I...
is it wrong to multiply for the denominator?
So you can, but it's just gonna be a lot of admin. So look at the step which we're gonna do now.
Okay.
So remember that for you to be able to substitute the h as 0, you must make sure that the denominator, so you must make sure that you don't have, let's say, something over 0. Immediately when you do not have something over 0, then you can start substituting the h is 0. So now let's put the h is 0 there. So when we put the h is 0, we drop the limit. So we have negative 2x minus 0 divided by x squared plus 2. The h is 0. We have x plus 0 squared plus 1 multiplied by x squared plus 1. So this here
You
becomes...
said substituting our h as 0.
So we can only substitute your h as 0 when, or if when you substitute that h, you don't get any. Does it make sense? So as long as...
No, sir, please repeat.
So as long as when you substitute h, you don't get division by 0, then you can now start substituting the h. You see, for example, at this point here, this line, if we put h is 0, we're going to have division by 0. Can you see?
Yes,
if we set the h is 0, that side, so
Yes.
you are going to have division by 0. But now after cancelling out these h's, we can attempt and see if we are going to have division by 0. So that's why I put where there's h, I now put the 0. I put h as 0 and see. If I get a division by 0, it means I was supposed to do some more simplifying, or I made an error. To always cancel the h which is on the denominator. So let me say aim rather here. So aim is to cancel this h, this one here. Once we can cancel it out, things are just going to work out. You can now start putting h as 0. So me, I have now cancelled that h here. So the aim is to make sure you cancel that h out. After it's out, we can now...
So, sir, you're muted.
So who is muting me?
Ibaka, but sir, may I ask?
Yes.
So what you're saying here is that we can only substitute h is equal to, we can only substitute 0. We can only substitute the value that's h up. Sir, can you hear me?
Can you please repeat? It looks like there's a person in the meeting who's busy muting all of us. It's a problem. Really interesting person.
Sir, I wanted to confirm that you can only substitute the value that h approaches only when you're not going to get an undefined answer.
Yes. So look at what I said here. Let me minimize the screen. So I said the first thing when you do these problems, you should aim at canceling the h which is there. The h which comes at the denominator, your aim is to always cancel that h. Once you have found a way to cancel it, just like what we did here, above here, you can now start substituting your h as 0. But the aim is to cancel that h with another h, which will show up in your expression if you do your simplifying okay. So that's the aim. When they say first principle, your aim is to cancel that h which is in the denominator. And if you work your solution good enough, you'll be able to factor something out on the numerator, which will cancel the h on the denominator. And after canceling that h, you can now start putting, where you see h, put a 0. Does it make sense?
Yes, yes, thank you, sir. So when you have substituted your 0 and your h's have cancelled, do you continue simplifying?
If you can, if time allows you, you can. For example, here, this is really nothing deep. We just need to put x squared plus 1, and then we have another x squared plus 1. So our answer here is negative 2x over x squared plus 1, all squared. So it depends on the amount of time you have. So if you feel like you can even simplify more, then good for you. But please be time weary. I think after reaching the step here, make sure the one which is coming here is usually your last step, because time is really not on your side. You need to write those 2 tests in 1 hour. So you don't have a lot of time.
All right. Thank you, sir.
1 hour straight.
Yes. So I think you have 30 minutes for algebra, 30 minutes for calculus.
No,
If
it's
it
75
had
minutes.
75.
24 minutes for algebra, then 36 for
Yeah,
calculus.
75 minutes though.
24 minutes for algebra, 36 minutes for calculus. How is it 74?
They sent us. They stated that the test will be 75 minutes long, even though it's out of 60, I think.
Okay, no problem. So okay, it doesn't matter. Either way, the time is not as long as you might think it is. You know, the earlier you finish, the more time you have for solutions. So let's look at question 4. We are moving very slow. So let's look at question 4 there. So question 4. So for question 4, they're saying y is sine x plus cos x. And they're saying find the equations of the tangent and the normal to the curve at x is 4. So this needs our high school knowledge. Equation of not a, but the tangent to the curve. So if you remember, you guys, please remind me, when we find the derivative, what do we define the derivative as? But let's first find the derivative. What is the derivative of y here?
It's cos x minus sin x.
Cos x minus sine x. And when we speak about the equation of a tangent, what is the derivative? Or what is it?
It's the gradient.
It is the gradient of the tangent at any point. So you only need the specific x value, you'll be able to find the gradient at that point. So this here is the gradient of the equation of the tangent at any point. So this you need to be aware of. So now they gave us a specific point. They gave us that x must be pi over 4, meaning we can find the gradient at pi over 4. So our y dash at x is pi over 4 will be equal to cos of pi over 4 minus sine of pi over 4. So good people, what is cos of pi over 4 and what is sine of pi over 4? This is m. Let's call it m for gradient.
They are all 1 over root 2.
So we have 1 over root 2 minus 1 over root 2, which gives us 0. So the gradient is 0. So now we know the equation of a tangent. The tangent is a straight line. It is y is mx plus c. Okay. So now we need to figure out what is c. Our m, we saw that it is 0. So for us to figure out what is c, we need a coordinate. And how can we get the coordinate is when we substitute y, when we find y of pi over 4, which is just sine pi over 4 plus cos of pi over 4. So our y here will be sine of pi over 4 is 1 over square root 2 plus 1 over square root 2. This gives us 2 divided by square root 2. And this is just square root 2. So which means our y is square root 2 when x is pi over 4. So we can, when x is pi over 4. So our y is square root 2 when x is pi over 4. So we can now use this to find our c. But we can clearly see that for y, when we substitute back, it is square root 2.
Wait, sorry.
Yes.
Can you please repeat? Because like I lost network.
Okay, where did you get lost?
From y, yeah, from x is equal to pi over 4, literally.
From x is pi over 4. So you remember that the gradient, or when you find the derivative, what you are finding is the gradient of the equation of the tangent at any point. You remember?
Yes.
Right. So we are given that the point is that x is pi over 4. So meaning we are given a specific point. So we can find the gradient of the tangent at that point. So that's why we take the derivative. And where we see x, we put pi over 4. And guess what? You get 1 over square root 2 minus 1 over square root 2, which gives you a gradient of 0.
Okay.
Right. But we know our tangent should be a straight line, which is y is mx plus c. But our gradient, which we obtained, was 0. Right.
Yes.
So for us to find c, we need another coordinate. We need a coordinate which lies on the curve. So that's why I went back to the original expression. Where I see x, I put pi over 4 to get the corresponding y value. So we put x, and then we get sine pi over 4 plus cos pi over 4. They sum up, and the answer we get is square root 2. Are you following?
Yes.
Great. So now we have a coordinate. The x is pi over 2, pi over 4, and the y is square root 2. So we can now go to our linear equation and substitute back this. Our m is 0. Our x is pi over 4 plus our c. So here we can clearly see that our c is square root 2. So please, good people, check your mic. You are talking to your friends and we can hear you. Just go run to your PC and see if you are the one who's not muted. So our c is square root 2. So therefore, the equation of a tangent is simply y square root 2. Okay, and whoever was giving you this is very happy.
Sir.
Yes.
So I'm sorry, can you please repeat what you did after you got that the gradient is equal to 0? I got lost after that.
So after I got the gradient 0, can you see mx plus c? So meaning I need one x and y value to and one y to be able to solve for c.
Yes.
So I took the x is pi over 4, plug it back to the original expression, which is y is sine x plus cos x, so that I can get a corresponding y value. So I need one coordinate to find c because I already have m. Does it make sense?
Yes.
Great. So when you put pi over 4, you get y as square root 2 as your corresponding y value. Right. Then now we can go back to our y is mx plus c, where you see y, put square root 2. Our m, we obtained as 0, but where you see x, you should put pi over 4 and then plus our c. And we can see that our c is square root 2. Do you understand?
Yes, sir. Thank you.
Okay. Then finally, your y becomes square root 2 because your gradient is 0. So that's our equation of the tangent. Right. So this is sorted. So if you think carefully now, because they said also they are looking for the normal to the curve. So normal, remember, the tangent touches the curve at one point. The normal will just be perpendicular to the tangent. So you have a sinusoidal graph here. It looks like this. You don't need to sketch it with accuracy. So it looks something probably like this, whatever it looks like.
Sorry, sir. Can you please repeat the difference between the normal and the tangent?
So let's see. So the tangent touches the graph at one point. So let's say our pi over 4 is somewhere here. X is pi over 4, right? So our tangent would be like this. It will just touch there. Okay, and then, so this, in fact, let me write it like, let's push the pi over 4 to here. So x is pi over 4. So this is just a sinusoidal graph. So the tangent, because it is a straight line, y is square root 2, it means the tangent is just something like this. So it is not tilted towards the x's, it is just y square root 2. That's just a straight line, we all know. And the normal is perpendicular to the tangent. So that's one thing you need to be aware of, that your normal must be perpendicular to your tangent. And this here is your tangent. So we know very well that y is square root 2 at x is 4, is pi over 4. So that's why our normal equation will just be pi over 4. It will be x is pi over 4. So your normal should be perpendicular to your tangent. So do we have a question? The person who posed that question, are you answered?
Yes, sir.
Okay, great. So there's question 5. So any thoughts on question 5? Do we have any question on question 4 before we move? So this here, let me write it as takeaway. So people like takeaways.
So can you please just see the whole question 4, take it down before we move on to question 5?
Yeah. So what I'll do is I'll share this PDF in the group. So you don't need to stress. Unless you want to see and then ask a question.
Sir. No, it's okay. Thank you.
Okay, cool. So you'll have access to these in case you are frightening and you are trying to write at the same speed. So let's quickly jump into question 5. But let me say takeaway. Currently, students like takeaway. So
can I ask?
Yes, you can.
So does this mean that the gradient of the normal is 0?
Impressive. So the gradient of a vertical line is actually infinity. Can you think about it? So look, so here's
I
what,
hear you.
yeah. So the gradient of a vertical line is infinity. Then the gradient of a horizontal line is 0. So you can note that down. I don't know when it's going to be useful, but maybe it isn't going to be useful in the future.
Okay, thank
So,
you, sir.
Yes.
so is the gradient of the norm of the vertical line infinity or undefined?
Infinity is not defined. We don't know what it is. So essentially, it's the same thing.
Okay.
We can't define infinity and give an exact value to it. So it's undefined if you want to use those terms.
Okay, thank you, sir.
Yes. Apparently there's greater infinities. There's one infinity which is greater than the other one. Sounds crazy. So let's look at question 5. Let's see what we obtained. So I need someone to read question 5 for me. Open your mic and be the reader. Let's contribute.
Okay, says given that a cylindrical can of radius r and height h must have a volume of 2000 centimeter cubed, find the value of the radius that will minimize the total surface area, and use the second derivative test to show that your answer will indeed give a minimum. Hint, find the height in terms of the radius first.
Okay, so we are given the volume of a cylindrical can. Maybe the question we should be asking, this is just the cylinder. What is the volume of a cylinder? Someone should just throw me the formula. The volume formula of a cylinder.
I think it's pi r squared h.
Pi r squared h. Pi r squared h. Do we all agree or someone else knows another formula? So I'm taking what you are saying and then I'm going to use it.
So, sir, is the cylinder closed or opened? Because I think they are different.
So if
it depends if it's closed or open.
So if it is opened, the question is the volume formula, does it change? So if a tank has the lid open, does it mean it can take less water than one which is closed?
Volume remains the same.
Yes. So for volume, it doesn't matter. Maybe it's the surface area which matters, because it would be really interesting that imagine a bottle when it's closed, it can take in more water than when it doesn't have a lid. It would be really interesting. Funny thing to think about. So let's think of the surface area. So what is the surface area there? So someone please give me the formula of the surface area when you're looking at that sketch there. So what can we choose? Because on Monday, you need to look at the problem and then say, okay, what's the area which I can start from here? So what is the surface area here?
Do you need the formula?
Squared plus 2 pi RH.
Okay, so let me do this. Let me quickly sketch it here. So they drew this way. So it's a tank. Okay, someone who's good in drawing must give me lessons in drawing, please. So let's see. So we have R here and we have H. And then when they draw it, the other side it becomes something like this. And then this is the vertical. This is from here to here, essentially. And then now we have that, which is the lead on the other end, and we can draw the lead, other one this side. It really doesn't matter. So the question is this open or not? So we need to find the surface area. So someone please give me what the surface area is. But one thing we know here is that we have radius r, and that from here, the center to down there, it is r. So can we all agree that from there to there, it is 2r? Okay, give me a sec. Let me finish this sketch. I'll give you some time to respond. Then from here to here, it is h. So you can shoot.
Can the surface area be 2 pi r h plus 2 pi r squared?
So let's see, 2 pi r h. And then plus what?
2 pi r squared. No, it's just pi r squared because there's. Did they say there's a top or something like that? If there's no lead, then it's just pi r squared.
Okay, the person who read this, let's see. Must have find the value. Use that. Cylindrical can. So one thing we need to be clear of here, should we assume it is closed or it's open? Cylindrical can, we assume it's open, the top, you want to drink. Or what?
It's closed.
I think we can assume that it's closed because it didn't say anything about it being open.
So here's one takeaway you should, or one thing you should be aware of. If on Monday you read a question and it's not clear, raise your hand. Raise your hand and ask. You see, for now, we're asking ourselves, was this closed? Is this a closed can or an open can? Because it changes the surface area formula. So if you encounter such problems, just raise your hand and ask, should we assume it is closed or open in case you encounter a problem where it's not apparent? So let's assume that it is closed. So what would we add here?
2 pi r
2 pi
squared.
r squared.
2 pi r squared. So I hope it's all apparent why we are doing this, good people. To those who are not aware, the area of a circle is pi r squared. Okay, and you have two of them, two circles. The area of a rectangle is the length times the breadth. So the length there we can see it is h, the breadth we can see it is 2r. The length and the width, yeah, sorry. So that's why we have 2 pi. Okay, impressive. So at the same time, remember, made one mistake here. There is this element of being like that. So we need to put a pi there. Or rather, just remember this, you don't need to try and derive it if you find it really, if you see it as complicated. Let me leave it as such. So what we are given here is the volume. The volume is 2000, whatever units squared. So the hint they are saying we should find the height in terms of the radius. So we know that the volume is pi r squared h. So they're saying find the height in terms of the radius. So it means we need to just say our height is equal to 2000 divided by pi r squared. And there you go. We have found our height in terms of our radius. Let's make this small and put it there. So after finding our height in terms of our radius, we can now go and substitute on the formula for the surface area, because we are looking at the values which will minimize or maximize it. So our surface area is equal to Where we see h, we'll put 2000 over pi r squared. So we put 2 pi here, and then we have our r, our h, we have 2000 over pi r squared, and then plus 2 pi r squared. So let's quickly solve that. So what we have is S is, the pi's are gonna cancel. And then what we have is simply 4000 R. In fact, even the one of the R will cancel. So we have 4000 over R, and then plus 2 pi R squared. Do we have any question here? Are we missing anything? Do we all agree?
Yes.
Okay, so let's quickly now look at maxima and minima. So you know when they're speaking about maximum and minimum, we need to go to the derivative. So let's find S dash. So the derivative of this will be, if you remember your differentiation, negative 4000 over R squared. And then plus, someone is unmuted. Do you want to ask a question? Okay, derive 2 pi R. No, there's no 2 here. Do we have a 2? Yes, we do. 2 circles. So we have 4 pi R here. And we know for maxima and minima, we need to equate to 0, get the R value, plug it back to get the maximum or minimum surface area. But in this case, we are trying to minimize it. So let's equate to 0 and solve for R. So we have negative 4000 over R squared plus 4 pi R. This is equal to 0. So we can multiply by R squared both sides. And what we obtain is negative 4000. That gives us plus 4 pi R cubed. This will be 0. So you can transpose and get 4 pi R cubed is equal to 4000. And then if you divide by 4 pi there, you get R cubed is 4000 divided by 4 pi, which is just the square root of 1000 divided by pi. Right, so this is what we have. Any questions? Any questions here?
Sir, is it the square root or the
Actually,
cube root?
it is the cube root. Thank you. Silly mistake which you can easily make on a test. Cube root. So the cube root of 1000, we know it is 10. So we have 10 cube root of 1 over pi. So that is our R. So I need to remove my R cubed here. So my R is that 10 cube root of 1 over pi. Do we have any questions?
Sir, can you please repeat from where you started to derive?
Okay, so you mean here, do you understand that the derivative of 4000 over R is the same as negative 4000 over R squared?
No.
Okay, so this could be, it's something like this. What's the derivative of 1 over x? You would typically want to write it as x to the negative 1. And then this would be negative 1, x to the negative 2, isn't it? Which is the same as 1 over that. Agreed?
Yes, sir.
Yes, and then all what you do is you multiply it by this 4,000. Ooh, there you go. Makes sense?
Yes, sir.
Then this, think of it as the derivative of x squared. Derivative of x squared is 2x. So derivative of r squared should be 2r. So 2r times 2 pi, it is 4 pi r. Makes sense?
Yes, sir.
Okay, great. And then after deriving, one thing we know is if we are looking for the maximum or minimum of whatever function we have, we need to equate the derivative to 0, solve for the value of interest, and then if they need the maximum or minimum surface area, we can plug back the r. So that's why we equated the derivative to 0. And our aim here is to solve for r. So look, we equated the derivative to 0 here, and then we multiply it by x squared all over to remove that x in the denominator. We dislike fractions in general. So when you multiply by x squared all over, this becomes not x squared, but r squared. This becomes r cubed. Then from here, it's just a matter of solving for r, which you can divide by 4 pi and then take the cube root. And you cancel the 4s, you left with 1,000. Cube root of 1,000 is a 10. And then whatever which is inside, which we can't work out the cube root for, on top of my head, we leave it as it is. Do you understand?
Yes, sir. Thank you.
Great. So let's see. That's question 5. It was the last question.
I have a question, sir.
Did we ask? Yes.
What if you just say 1 over pi to the power of 1 over 3? Would they still mark it wrong or?
To the power of 1 over 3. They wouldn't mark it wrong. It's still the same thing.
Oh, okay.
Yes.
Okay, thank you.
So now they're saying use the second derivative test to show that your answer will indeed give a minimum. So someone, please unmute and remind us what is the second derivative test. So rather than doing it, we need to know first, what is it even? What are we testing here? So anyone, please remind us what is the second derivative test? I'll put a question mark here. Your 10 seconds will be really appreciated. Second derivative test.
Okay, so what I think is that what we are trying to prove is if we find the second derivative positive, then we know we have a minimum. But if like our second derivative, we find that it's negative, and then we know that we have a maximum. But that will be after we have substituted our x.
Okay, so the second derivative test, that's the question mark. So if I heard you well, you were saying, let's consider, so we are considering the turning point, okay? Turning point, or let's rather say, call it critical point. So if our critical point, let's call it x is c. So we'll find the second derivative and put c as x, okay? And then if this is less than 0, we have something else. And then if we take the c again, and we find out that it's greater than 0, then we have something else. So now my question would be also, do we ever have a case where we have a 0? But let's come here. So please give me what I should be putting near these here. So someone, please unmute yourself and tell me that, look, for the first one, if we find this, this is the conclusion.
Okay, so for the first one, if it's less than 0, then it's the maximum. And if it's greater than 0, it's the minimum. Then if it's equal to 0, it's a point of inflection.
Maximum. And then if we find out that this, you said, Is it minimum? No. Can you repeat? And then one of your classmates is gonna confirm. Let me pause. Repeat what you were saying, and then a classmate will confirm.
Okay. So I think when the second derivative is less than 0, then it has to be a maximum. Then when it's greater than 0, it has to be a minimum. Then when it's equal to 0, it's a point of inflection.
Okay, great. So noted. We have anyone else who has a different answer? So we are all trying to converge to something here. So you can unmute, and then if you reckon what they are saying, just give them a thumbs up. Okay, so minimum. And then here, point of inflection. And if you remember, the point of inflection, that's the point where you essentially change from concave up to concave down. Okay, so which means we need to find the second derivative here. Let's copy the first derivative and go figure out what's the second derivative, and then plug in that R value and see what we obtained. There we go. So they needed us to go and find the second derivative here. So second derivative. Here, let me see, -2 times that. It will be 8. So it will be 8,000 over R cubed. And then plus 4 pi R. So now I can put my critical point, which is R. It is 10 cube root of 1 over pi. So here, this, let me just rewrite it as that which I had before. I think it makes my life to be easy in this sense. So our S here, S second dash, will be our 8,000 divided by our cube root of 1,000 divided by pi. This is all cubed. And then plus the second derivative should not have an R here.
Sorry, sir.
Yes.
Oh, never mind. I wanted to ask about the 4 pi R on the second
Yep.
derivative. That was here.
Thank you. Thank you.
Okay.
So let's quickly create some space and see. Obviously, from here, we can all see that it's going to be greater than 0, but let's quickly compute that. So we're just going to have 8,000 divided by 1,000 over pi plus 4 pi. So this will end up being that. So this will end up being 8 pi plus 4 pi, which will be 11 pi. And guess what? Our second derivative is greater than 0. So this is indeed a minimum, as they said, we needed to minimize. So we have confirmed. So the second derivative test, this is your takeaway here. You need to make sure you know this. And write takeaway here. You can't enter Monday not knowing what you should do when they are saying use the second derivative test. That's the summary. You find the second derivative, you look at the critical point where X is C, where C is the turning point. You substitute and check, is it less than 0, greater than 0, or equal to 0? Depending on the answer, you decide if it's a minimum, maximum, or it's a point of inflection. Any question?
So, can I please ask?
If you
You can ask.
Okay, so I wanted to ask if my final answer, say for example, is 2 over
From where you would like to a second derivative.
If your answer is what?
Is, let's say, 2 over root 2, if it's my final answer. Do I have to rationalize it, or can I leave it as it is?
You can leave it as it is.
Okay.
Okay, great. So, yes.
If you did not substitute.
If you did not what? Can you repeat? Kindly repeat. I think you are cutting. You were saying if you did not what?
If you did not substitute the value of r on the second derivative, but by looking at it, it's positive, is it a must that you must substitute, or you can leave it as it is and just finalize your answer and say it's a minimum?
Okay, so think of it this way. So everyone says, look, so let's say you are the one who's marking. It's easy to guess. So how do you then differentiate someone who's guessing and someone who's not? Let's say I know the answer on top of my head. It looks apparent that this is minimum. But then how do you differentiate between someone? Yes.
But R is a distance. Can it be negative?
No, it cannot be. But the question is, how do you then differentiate between someone who didn't have time to even substitute back, and someone who was guessing, and someone who actually knows the work? There's only one way you can differentiate is if the person has clear steps and they have their final answer. So my advice is it's all time dependent. Make sure you write every single step which you feel like matters, because probably the question there would be 2 marks or 3. So why would you derive, and then from there you are saying therefore it is minimum? How do you see from the derivative that it's minimum? Because you need to substitute C, which is a critical point. So look at what we wrote as takeaway. It is not f of x, but it is the second derivative with x as C. So meaning you must substitute. So it sounds, I understand where you're coming from, but depending on who's marking, you'd rather just do all the work than to try and fight them later and say, look, it was apparent here, R is positive and we have R cubed there. Something positive cubed, it's just going to be positive plus something positive. So please write your work if time allows you. Write every step which you feel like matters. Okay.
Thanks, sir.
Great. So this concludes the calculus paper for 2019. It was a sweet one. It was a really sweet paper. Let's see how many pages we took. Not a lot. Not a lot at all. So this concludes the calculus paper, good people. Any questions related to that paper?
So can you repeat the last part, like where you took the second derivative?
The last part, do you mean this one? Okay, do we have any question, good people? Should we jump into algebra? Maybe that's the question I should be asking.
Yes, let's move on.
Okay, so let's quickly see. Yes.
I want to ask, how did you get the cubic root of 1,000 over pi? I'm lost.
Okay, so you remember what our R was. Here's our R here.
Okay, yes.
And then we had 1,000 inside, and the cube root of 1,000 gave us a 10. So I'm reversing essentially, because I see on the expression I have a cubed, and that's just going to easily work out. In fact, you don't even need to go there. You can put in the 10 cube root of 1 over pi there, and then you'll cube the 10, cancel the square root. It's going to work out to the same answer.
Okay, thank you, sir.
Okay, cool. So let me, on the group, quickly forward the paper, which is algebra, same paper, 2019. So the idea here is for you to get a feel of how the paper at least looks, or how it is structured. So please check the group. So there's a paper which has been forwarded just now. And if you open that paper, we have algebra Okay.
Doesn't this one belong
to one? No. This is tuned. So let me see. Where is the algebra 2019 paper? Did I get it? Okay, it's not in the group. Does anyone have the 2020 algebra paper? Does anyone have it? 20, let's see. That algebra. Okay, someone forwarded that. Algebra 2019 April. Okay, great, thanks. So let's quickly dive into that algebra paper and see how you are supposed to answer the questions. So let me see. Already there's answers there, but from experience, people fail even when they have the memo because it doesn't make sense. You actually do not need to know a specific question, you just need to understand. So let's say here, algebra, and then we will start that on the next page. So please check the group. Thanks to the person who forwarded the paper. So let's quickly jump into question 1 of 2019 algebra. So this is 2019 April algebra. So our question 1 is on long division. So you guys should essentially
Sir,
know long division. Yes.
sorry, can I ask, how does one join the group? Because I'm not in it.
You are not in the group. Okay. So here's what we can do. Someone who can, please take that. Can you now access the chat? Which group are you on?
So, what do you mean, which group am I on?
Okay, I'm asking you, which groups are you on? Or which group did you get the link on?
Someone sent me the link. I'm not part of a group where I got the link of the meeting.
Okay, hectic. Who is that someone? Okay, no problem. So here's what I can do. Let me quickly assist you there. So just give me your number. Sorry to the others.
So should I just say it out?
Yes.
Oh, 064.
Someone is writing them down. Yes.
064 9000.
9000.
910.
910. Okay. Yes. So 064 9000 910. Okay, not 900. 9000. Yes.
I'm also not in the group chat.
Me too.
So I think there's quite a lot of us.
Okay, let me. Please mute yourself. It feels like who's watching TikTok? You are really being distractive. So someone, can you now access the chat or the chat section? So someone who can access the chat section, please copy the link on the group, paste it on the chat section, and then the others will be able to join and access the paper. So for now, all what you need while we wait for you to join, let me carry on. I'll write the question here. So someone will paste the link on the chat section. Okay, let's go to question 1 and see what is expected of us. So from question 1, essentially, you need to use long division. So let's write it as note. The note to yourself that you need to know long division before you go to the test on Monday. So note, know, or let's say revise long division. So this is one thing you should do tonight. Okay, so let's see what's going on. So we have a rational function, an improper function, sorry, not rational, let me just call it f of x, which is 2x cubed divided by x squared minus 1. So they are saying for A, using long division,
So where can we access the paper? Somebody's asking that in the group chat.
so where is the paper? It is the paper which has been sent by Betty. So it's the one that is sent sticker. So that's the paper. This is the type of content I like seeing. So you can check out the paper, but I'm going to write at least here the question long enough for you to be able to follow. So they're saying using long division, you must write f of x as a polynomial in the form given below, which is the form is f of x must be q of x plus r of x divided by b of x. So we need to do long division here. So let's quickly come and do our long division. So we are dividing 2x cubed with x squared minus 1. So the first thing you always do with long division, you know, 2x cubed divided by x squared, we get 2x. Take the 2x, multiply it there, and then we put a minus here. You get 2x cubed minus 2x. You take the difference, and what you obtain is simply 2x. So which means when you divide these two, so remember that this here will be what we can call it's not a factor. Okay, let's call it a factor. The left of it. And this here is what we call a remainder. And all what you need to do then is that you need to equate your answer as. So after doing long division, your answer is always the factor plus. So let's call what was here. Let's call this here, for the lack of a better word, let me call it divisor. Forgive me if this means something else to you. So your answer should be the factor plus the remainder over the divisor. So if it means something else to you, please bear with us for this problem, because I need you to get a sense of what is going on. So which means our answer essentially is equal to, for factor, it is 2x plus remainder, it is 2x. Our divisor is x squared plus, it's minus 1, not plus, x squared minus 1. So comparing with the original equation, we can see we have achieved that form where q of x is 2x, rx, which is the remainder, it is 2x also, bx, the divisor, it is x squared minus 1. So this was easy marks. Any questions? Okay, so if there's no questions, then let's move, good people. We are looking at B. So for B, they're saying split the proper rational function part. Split the proper rational function part into partial fractions. Okay, so we can see that from our answer, we obtain 2x plus 2x over x squared minus 1. When they're speaking about the proper rational part, they are speaking about part, not function, proper rational part. So this is the proper rational part. And can anyone explain why is this rational or a rational fraction, if we may say? Let me say fraction. Why is this a rational fraction?
The degree of the
numerator is less than the degree of the denominator.
Okay. So this is proper in rational because the degree of the numerator is less than, if not equal to, should be less than, if not equal to, the degree of the denominator. By degree, we should all understand, we mean the highest exponent. So if you look at the numerator, the highest exponent is 1. The denominator, the highest exponent is 2. So 1 is less than 2. So that's why we have a proper rational fraction. So this one, which was given here, it was not proper or improper because the degree on the numerator is greater than the degree on the denominator. So 3 is greater than 2. Okay. So I'm glad if you guys know that. So let's quickly see. They are saying we should break this into partial fractions, 2x over x squared minus 1. So we know that we can write 2x divided by this, we can factorize into x plus 1, x minus 1. And this here we know it can be a over x plus 1 plus b over x minus 1. So now the question is, what is b and what is a? That's what we need to find out. And then finding out, you are good as done. So there's a number of ways you can work this out. Okay. One of the easy ways is just multiplying this. So we have 2x over x plus 1, x minus 1, and this is a over x plus 1 plus b over x minus 1. So what you can do, one of the things, here it's really dependent on what you prefer, but what I would do is I would multiply the left-hand side and the right-hand side by or with x plus 1 and then x minus 1. So whatever way works for you here, please keep it up. There's no way which works for you. Just take this one. So if you multiply both sides by these, you will cancel out the numerator on the left-hand side and you'll be left with 2x. the right-hand side, you will cancel out this part and multiply with x minus 1. B, you will cancel this out, and then what will be left will be x plus 1. And then from here to make...
Can I please ask?
Yes.
When do you know when to use the fraction or the denominator that has the plus first and the minus first? Like, which one do you use first? I don't know if you get me. For example, the x squared minus 1, when you factor it out, you get x plus 1, x minus 1. Do we always have to use the one with the positive sign first before the one with the negative sign?
No, you don't. So you can interchange them. We will get the same answer at the end. Okay, someone else can choose where there's A, they can have B, and where there's B, they can have A. After solving, even if we do the solving differently, at the end of the day, after plugging back our A's and B's, we are going to have the same answer. So you can, it doesn't matter which order you take. You can have A over x minus 1 plus B over x plus 1. Does it answer the question?
Yes, thank you.
Okay, so let's solve for A first. Or let's solve for B first. Solve for B. So for B, the question I need to ask myself, that's why sometimes you need to work smart, not hard. So for B, I can see that if I make x to be 1, this term goes away. So let me just set x is 1, that will cancel out the A there. So if I do x is 1, the left-hand side becomes 2 times 1 plus A, 2 times 1 equal to, sorry, A, 1 minus 1 plus B, 1 plus 1. So what we obtain is 2 is equal to 2B. So we can therefore conclude that B is equal 1. Anyone who doesn't understand what I did here?
Sir, can you please explain again?
Okay, let me solve for A. Let's see if you'll catch up. Solve for A, let's put it here. So what I'm looking at when I'm solving for A, I want only A to remain. So which means here, I want to eliminate this B. So if I do x is negative 1, this here, this bracket will be 0, so that works. So let's do x is equal to negative 1. The left-hand side, which is 2x, it becomes 2 times negative 1 plus I have A, no, equal to I have A. Where there's x, I put negative 1 plus B, I have negative 1 plus 1. So I can see that the B will go away because it will be multiplied by 0. So I have negative 2 is negative 2A. And when you divide both sides by negative 2 to solve for the A, we can conclude that A is 1. Does this answer your question?
Yes, thank you.
Okay, great. So this means that our 2x over x squared minus 1 is the same as 1 over x plus 1 plus our b is also 1 over x minus 1. So this is how this looks when we break it into partial fractions. Easy maths. Any question? Do we have any questions, guys? Okay, there's no questions. We progress. Let's quickly jump to question 2. Yes.
So, like, why are you not like taking the final answer? Since it was irrational at first and we divided, and then why are you not adding with our q of x, which is 2x, like 2x plus 1 over x plus 1 plus 1 over x minus 1.
Okay, so let's quickly go back to the question and see if they just wanted us to figure out the partial fraction of the second part. Split the proper rational fraction part into partial fractions. So now what you want us to do is that you want us to say that our f of x is equal to 2x plus 1 over x plus 1 plus 1 over x minus 1. This is what you want.
I was asking why is it not so? Maybe it's because I missed the question.
Yes, so the question is saying split the proper rational function part, which is what we said here, proper rational.
Oh, I get it. That's it.
Sir.
You can ask.
Oh,
Please
sir.
ask again. I missed the question.
Oh, so I was just asking, isn't there like another way to do this?
Repeat the question again.
Sir?
Can you guys hear me?
Yes, I can hear you now.
Give me a thumbs up if you can. Okay, great. So people can hear me. Someone raised their hand. So please remember, I cannot see the screen, good people. So kindly unmute if you have a question. I see. So let's quickly jump to the next question, which is question 2, and see what we need to take away from there. So we have question 2. So our question 2, they are saying the following identity might be useful. So let's write that useful identity. So that useful identity, it is tan of A plus B, which is just tan of A plus tan of B. And then it is divided by 1 minus tan of A, then tan of B. So now they're saying calculate the following.
Cha siyabonga Luyanda, bye bye.
Hey.
Well, Luyanda mfethu, how
Bao ke botsisha. Bao ke botsisha. Ya ke bala lena.
Is the session over?
Asazi.
Oh, guys, ngiyaxolisa.
Where is the tutor? What's happening, guys?
Niyabona ke, Monday ngizongibhalela. Wemonje mfethu angiphinyama.
Manje.
What's happening? It can't be.
Is it over?
I don't think so.
Course is not chowing. Chowing is chowing course.
What's going on?
There's a lot going on.
A lot is going up. You.
Ew.
So it's over, okay?
Yeah, guys, at least plagiarism is 80%.
What? Plagiarism yenzani?
Ngoba sengehlule sithela nopoison ngife.
Ngoba senza mekonke upoison ngife. 4:10. Boom. Indli yawa. What? Indli yawa ke manje.
Don't I get imagine having someone that knows you, boy.
Yo, guys, can someone please text in the group if the class continues?
Yo! Yazi uma umfundi awumele ukufunda usuku konke ulale ngo-4 ekuseni uthi uyabhala uvele uthole wona lo-4 ulale.
Okay, guys, I'm back. Can you see my screen? Please give me a thumbs up.
Yes, sir.
Yeah, we can.
Okay, no problem. So I only realized now that I was off. So let's look at my screen and then you tell me where did I stop? At least where did I cut? Wasn't aware I was off. So all along I was talking. Where did I lose you?
At the beginning of the question.
Beginning.
At the beginning of the
let's see. Okay, so let's see if we can unpack it. So the useful identity which was given to us was that we can use tan of A plus B, which is the same as tan of A plus tan of B divided by 1 minus tan of A tan of B. Okay. And they were saying we should calculate the following, which is the tan of arc cos of negative 3 over 5 plus arc sine of 5 over 13. So I chose to make those there to be A and B because we're given the useful angle or identity as tan of A plus B. Okay, so our A will be arc cos of negative 3 over 5, while our B becomes arc sine of 5 over 13. So you know very well that you can reverse the cos and put it this side, but since it was arc tan, this side, it's just going to be no arc cos. The side, it's just going to be cos of A is negative 3 over 5. And we do the same for the sine. Sine B becomes 5 over 13. So now what is useful for you to do? This is what I was saying. This identity which they gave us here is useful only if we can get tan of a tan of something. So tan of a tan of something equals something. Okay. So the problem we are facing here is that these A's here are in terms of arc cos and arc sine. But if it can be tan of something, the answer automatically becomes something. So that's why the reason why we are plotting these diagrams here, the two of them, is because we want to find out what is tan of A. So for the bold one, our hypotenuse, we are not doubting that it is 5. And since it is cos, we know that cos is x over r. So which means we are on the second quadrant since the x is negative. And then 3, 4, 5 triangle, we can easily get the 4 here. And then here, this is the 5, 12, 13 triangle. We can figure out what this part is. Okay, let me come here and see if we are still on the same page. Do we have any questions? Anyone with a question regarding what I'm saying?
So I'm lost on this problem, the whole of it, because you were gone and I got away from my laptop. I just came back. Can you please repeat it?
So let's do this first. So is there anyone who was listening here who could hear what I'm saying or see what I was saying?
Yes, sir.
Okay, there's thumbs up there, so which means people do get what I am saying. So here's what I can suggest to you. So please check out the recording again. Okay, but all what we were doing here, we had to take one of these inside here and make it A, the other one make it B. That's what we did here. But then, you know, since it's a cos, you can take it to the other side. It becomes cos of A is equal to that. Sine of B equals to that. So we can then plot this here. From this trig ratio, we can plot this graph. Sine, we know it is y over x. So there's our y. There's our b. Our hypotenuse is 13. This other side, when you calculate, you get 12. Okay.
Thank you.
And then,
thank you, sir.
Right. So now we have our b in terms of arctan, because we want to go back there and put the b. But we said when we have tan of arctan of something, the answer is something. So let's figure out a in terms of arc, in terms of tan. So our tan of A will be tan is this divided by that. So we have negative 3 over, it's negative 4 over 3, in fact. 4 over 3. So which means our A is simply the arctan of negative 4 over 3. So now we can go and plug in our answer using the useful identity which they gave us. We are so happy. So let's go. Equals to, we are using the identity. We have turned off our A. We can see we will use these. Yes.
Can you please explain why we use the second quadrant for cos A and not the third quadrant?
Okay, let's see. Not the third quadrant. So it would still work. So let's think carefully. Which quadrant should we use? Let us gather our thoughts together. So which quadrant should we use?
The second one.
Why not the third quadrant? That's what the person is asking.
Because if you use the third one, the y will be negative and the x will be negative. So the answer is going to be positive. And on that case, it is like negative 4/3, not negative 4/3. It's negative 3/5, which means something has to be negative. Hence, you have to use the second one.
But then on the third quadrant, your x will still be negative. Your r is always positive. So
I meant the y. The y will be negative there.
Mm-hmm.
Yeah, so if you use the third one, x is going to be negative and y is going to be negative. So the answer is going to be, the hint there is negative 3/5. If you use both negative, it will be positive. So that's why you have to use the second one only.
I understand what you're saying. So, but look at this way. So if we draw the third quadrant, okay, the angle becomes like this, A. So you have -3 here, you have your 5 here, then you have your -4 here. So you can see that cos of A will still be, let me look carefully. It will still be, yes.
Okay, so the thing that I'm seeing is that for tan, we have to check where tan is positive, right?
Mm-hmm.
Tan is positive on the first and the third quadrant, right?
Mm-hmm.
And then we check for cos. Where is negative?
Cos,
it will be on the
second and third quadrant.
Therefore, there's a, what do we call this? A flip. There are 2 ticks for the third quadrant. Therefore, we're going to use the third quadrant. That's what I think.
So why are you saying there are 2 ticks for the third quadrant?
If you check, like, how can I put it like? For tan, it appears on the first quadrant and on the third quadrant. And then for negative cos, it's on the second quadrant and the third quadrant. So for the third quadrant, there's some sort of like, what can I put this thing? I don't know. I don't know, so how can I put it?
So it's like on the third quadrant, we have more information compared to the second quadrant.
Yes, yes.
And what is more information?
It's like we have tan being positive in the third quadrant, and we have cos being negative in the third quadrant.
Yeah.
Did you include sign?
Sign.
But why are you including tan? Because this is all what we had here. So let's first, let me see if I'm following. So this is all what we have, this and this. Agreed?
Yes, but the original equation has tan.
Mm-hmm. So you want to force tan to be positive. So the question is, do you want tan of A plus B to be positive or negative?
Where it's positive, it will be in the first quadrant and the third quadrant.
Mm-hmm.
Yes, and then for cos, where cos it's negative, that in the second quadrant and the third quadrant.
Mm-hmm.
Therefore, we can conclude that, yeah, it's the third quadrant.
Okay, so what if we say we want tan of A plus B to be negative? You want tan of whatever angle which is there to be negative.
Don't get your question.
Can I explain why it's in the second quadrant?
Yes, you can.
This is because it's arcsine. And in order for arcsine to be a function, we have to restrict it. And when you restrict it, we know it starts from 0 till pi. And from pi, it's first quadrant and second quadrant. That means it cannot exist in the third and the fourth. So we know we are looking for it where it's negative. This is why it becomes in the second quadrant, because the first quadrant only exists of positive.
Yeah,
That's the reason.
The gentleman who spoke now is what are you eating? We need what you're eating. We need it. You should tell us what is he eating. So we need to eat the food he's eating. No, it is very smart. So here's what he's saying. So do you remember that, for example, so this would be from inverse functions. This gentleman is extremely smart. Inverse functions. So this I cannot really comment a lot. It's something which you guys would need to go into revision on. So let's say, for example, you have a sine function, or let's take a cosine function, or let's just take a sine function, okay? So this is our sine function, y sine x. And then let's take its inverse. So for this to be a one-to-one function, when we do its inverse, it's all what I do, I just flip the x's. So I cannot have, so I'd either need to cap one of these two. It's either I need to cap, so what I can do is I can cap here, between here and here. And if I cut anything else, it becomes a function, when at least the inverse becomes a function, because then the inverse will look like, my sketching is really horrible. Okay, let me just take this graph and rotate it. Copy. And where do I rotate? Okay, this is good. I can't draw my graph. So here's what I think you should do. Please go to your inverse functions, and you will find what he is saying. So I wanted to explain it using a diagram, but I'm really struggling drawing that diagram. So I can rather write a note for you so that you understand why we picked that diagram. But thanks for your contribution. So let's quickly wrap up this question. Here, please remind me in a group to write a note or to attempt to draw a diagram or download a diagram, paste it here and explain what it means. But let's go back and put in our A and B and then conclude the problem. So we have arctan of, the arctan of our A is -4/3, and then plus the arctan of our B. It's the tan of the arctan of our B is just 5/12. and then divided by 1 minus the tan of -4/3, and then the arctan here, arctan of 5/12. So our answer here becomes, we have -4/3 plus 5/12 divided by 1 minus -4/3, and then 5/12. Yes, so the person drew the thing which I wanted to draw. So thank you. There's a person called Spectrum. Interesting word, or name rather. They were able to draw what I wanted to draw. So please check out their solution on the group. So this is our answer. You can leave it here. If you feel like you can simplify it, good luck. Do we have any questions? Any questions, good people? Should we proceed? Or you just look at the solutions which are there and then make sense of them?
Sir, can I ask something?
Yes, you can.
It might take us a little bit back, but there's a point where you said tan of something is equals to something, right? What if that something is a special angle? Maybe it's a pi/6 or something.
So they wouldn't give you, so let me see. So I said tan of arctan of something is something. So you can ask your question. What's your question?
What if that's something that is in there? It's a special angle, like it's pi/6. Is the answer still something? Is the answer still pi/6, or we have to get the relevant sides using special angles?
Okay, so the catch of that, number one, look, so let's say that something, let's say you have tan of, so they wouldn't give you things which you wouldn't be able to work out on top of your head. Because look at the problem which this presents. So this here is more like an angle A. So even if you wanted to, this would just be pi/4. Because something is pi/4. What do you mean? So the something in this case is pi/4.
Okay, I see. But I don't know where, but I think I saw something like when it's arctan of a special angle, we have to get like sides. And right, tan is opposite of adjacent. We have to find those opposite of adjacent of pi/4. That is what I was asking. Do we find the relevant sides, or we just go about with an angle to be an answer?
Okay, so here's what you can do. It's much more easier to address a specific question when it is there, and then you can explain the concept around it. So when you get that question, you can drop it in the group, and then if I'm available or people know the answer to that question, they will be happy to respond. So I think we can do that. It works more. Okay.
Okay, no problem.
Okay, great. So now my question is question 3. The answer there is apparent. I don't know if you guys want us to go over it. And let me see question 4.
Sorry, sir.
So 2 questions left, essentially. Yes.
Will they give us these identities, or should we like know them by heart or something?
I think what they will do is, at least for a problem which is complicated, they will give you a hint. But please make sure you know what you need to know. I don't remember if they actually do give you a formula sheet. I can check for you, but make sure you know certain identities, because it makes the problem solving to be faster rather than looking up every solution. So please make sure you grasp or you cram, for the lack of a better word, as much as you can.
So may we please go over
Okay, I cannot hear you.
May we go over question 3?
Question 3. So let's see. So for question 3, they gave you identities. So this makes your life to be extremely easy. Very easy. So let's quickly see. So question 3. Let's quickly jump into question 3, and then we might need to conclude ASAP. So let's look at question 3. General solution. So our question 3, they were saying we should find the general solution of the given equation below. So you can't go Monday not knowing how to find the general solution. And guess what? Those identities they gave you above there are really critical in you finding your general solution for some of these questions which are of the nature that is given. General solution of, so what we are given is sine 3 theta minus sine theta. They are saying this is equal to cos 2 theta. And guess what? They gave you identities, many of them even. I'll write the one which you can see immediately that it is relevant. So there's one identity which says sine of C minus sine of D is equal to 2 cos of 1/2 C plus D. So you're adding those angles. And then multiply by sine of half of C minus D. So this is the given identity here. Wouldn't kill if you would know this in case they do not give you. So this is an identity. So we can see that we have sine C minus D, and we can clearly see that our C is 3 theta, and our D is just the theta. So therefore, what's going on is that sine 3 theta minus sine theta will be equal to, we have a 2, and then cos of half of C plus D, which is 3 theta plus theta, and then sine of half of C, which is 3 theta minus theta, and this is equal to cos 2 theta. So this right here will be equal to 2 cos 3 theta plus theta will be 4 theta divided by 2. We will have 2 theta times sine of, so we have 3 theta minus theta divided by 2, which will be 2 theta divided by 2. It is sine theta, and this should be equal to cos of 2 theta, which was given on the right hand side. So we see things which are cancelling nicely. And guess what? We have sine theta equaling to 1, And then our sine theta, you solve for it, it will be 1/2. And this here, we need to plot a graph. So there's this one. So we have theta. I should have 1 here, 2. And then the answer here will be √3. So now the question is, what is theta? Let's try and make it look familiar. So let's think carefully. So let me refine. So there's 2 ways we can work this out. Let me think carefully. So let me rather, this is where, so this will be one solution. Okay, let's figure it out and we'll come back and refine this here. Or alternatively, what you could have done would have still pushed you to the same solution, but now you would have 2 solutions. So someone else would have said, look, let me take the cos 2 theta to the right-hand side and have 2 cos 2 theta sine theta minus cos 2 theta equals 0, and then factor out cos 2 theta. Then inside be left with sine 2 sine theta minus 1 equals 0. So which means here you would have cos of 2 theta equaling 0 and 2 sine theta minus 1 equaling 0, which would lead to the solution, which is this side, this one. Okay, so let's quickly finish up the solution on the right-hand side. So what is our theta there? So our theta can be the arc sine of 1/2, but we know sine is periodic with period 2 pi k. K360 back in metric we used to say. So what is arc sine of 1/2? So let me quickly fix this. So what should come here?
Pi/6.
And then there it's pi/3. So this means our answer is pi/6 plus 2k pi. And then now we have cos of 0. So let's quickly look at what this means. So the cosine graph looks like this. Typically. And here we are 2 pi. And then here we are at pi. Here we are at pi/2. And then here we are at 3 pi/2. So we can take the reference angle, which is the one on the first quadrant. That's where we have 0. So we can have 2 theta is equal to pi/2, then plus 2 pi k, then we can divide by 2. So our theta will be, when we divide by 2, it becomes pi/4 plus pi k. And there you go, these are your 2. Do we have any question?
Oh, sir, I have a question.
Yes.
So isn't it that the period for cos 2 theta is already pi/2?
Let's see. So 2 theta, it is already pi/2. What do you mean it is already pi/2? Please.
I get the period for a cosine graph is
2 pi.
Mm-hmm.
So when you introduce like a double angle, the period of the cosine graph is divided by 2.
Yes.
So the period of the cosine 2 theta is now pi over 2. So wouldn't that mean if we divide by 2, the period will be halved again?
Okay, so I see what you are saying. So what you are saying here is that, so here this is a general cosine graph. General. I'll quickly get back to what you are saying now. So you are saying the period of the, what you call cos 2 theta is already pi k. Do you agree? Because all what you do is you take the number, which is multiplying the angle, and divide the original period width by that number. Does it make sense?
Yes, sir.
So what are you saying?
So wouldn't that mean if we divide by the 2 throughout, wouldn't that mean we have pi k all over 2?
Pi k over 2. Yes, that also works because this here is the period of the function. So we can do exactly what you are saying. But one thing you should pick up is even if you had put the 2 pi k, they were not gonna kill you, let's say. They were not gonna make you to fail. Because if you go to theta and put exactly that 2 will multiply through and it will still work. But yeah, thanks. Your answer is valid. I'm not discrediting it. Okay.
Okay.
Any questions, good people? Okay. So if there's no questions, let's quickly call it a day. There's always more time in the group. We can ask questions. So this recording, yes.
Can I please ask, if you don't use the sign identities to solve this, would they mark you right? Because I got the exact answers that you got, but I did not use the sign identities, and it's long.
They wouldn't mark you wrong, but the identities are there to make your life to be easy. So you said you even took, or you said it is long. So I don't know how much time you took doing the problem. But when you get a chance to use something which is much more simpler, please use it. It's the same way. Let's say you are given a chance to drive from Limpopo to Cape Town, or you can take a flight. Which one would you take?
Take a flight.
Yes. So you wouldn't want to drive all the way, and then it's really tiring. So when you get a chance to use a way which is shorter, especially if they give you a hint, please go for that method. You will be okay, I promise you. So good people, if there's no question, let me call it a day. I'll share this PDF on the group so you can revise. Yes.
Sir.
Can you please clarify on on question 4 where like we're supposed to do R maximum and R minimum? Just these 2 questions only.
Drafting polar graphs.
Okay, let me quickly see your question 4 and look at R max and R min. For those values. So this graph was quite easy. So let's see. Sketch the graph. R is that. So let me write R here. R is 1 minus 2 sine theta. So what I do when I sketch these graphs, let me sketch it and then I'll answer your R max and R min. They said between theta is 2 pi and 0.
So pi over 2.
So the typical graph of sine looks like this. Okay, so this is what I do. So here I have pi over 2. Here we have pi. And then here we have pi over 2. Then here we have 2 pi. So this is, you can see the inverse graph. Since there's a negative, which means the graph goes this way, then it goes that way. And then they multiplied it by -2. So, which means that graph here, instead of being at 1 and +1, is at +2. Please check your mic. It is unmuted. Please check your mic, people. We do not want to hear what's going on around you. So if we draw this one, then it looks like this. We can turn there and then hit down. And then we push it by 1 up. When you push it by 1 up, let's do the purple one. So let's quickly drag these values here. That's your pi over 2. That's your pi, that, and then that. So when we add 1, so this was at, we put 2 here, the final graph I was touching based on, it was at 2. So it looked like this. And then when I add 1, it goes up. It shifts, it starts here. It turns here. Let me put -1 here. And then let me put 3 here. So it starts here, turns there, comes up here, it turns there. And then now, instead of ending there, it will end here. So now that's your new graph, the red one. That graph is your R is 1 minus 2 sine theta. Someone else can choose to just use points which they know, which is okay. So that's my sketch done and dusted, the red graph. So let's look at the R max and R min. Hence, otherwise determine theta values which give you R is equal to 0. So I'm looking for R is 0. Where is my graph 0? So we need to look here. Where is my graph 0? Let's quickly look. It is 0 here. Let's use black. It is 0 at this point. And at that point, we can see that our theta was pi. So theta is pi, makes our graph to be at 0. Is it? Yes. And then where else is our graph going to be at 0? It's somewhere here. And what is that point there? So alternatively, what you can do for that one is that instead of trying to figure it out, let me see, if you move it like that, you can just put your R to be equal to 0 and figure out what is going on. Solve your T. We've already found this on the previous page where you obtained pi over 6, which means the point which is here is simply pi over 6. And then the other point is there. So why am I marking pi there? Hopefully I drew this okay. If I push it up, it's no longer supposed to cross there. So I'll not rely on my graph. The sketch is not drawn according to scale. It's a mess. It's a mess. The pi is supposed to be up there. So be careful, good people. Let's redraw it because it moved up. So it's going to be here. So when we see R mix, determine R mean. So our R max, we can see the maximum value of the graph here is when we are at 3. So our R max is 3. And our R mean, we can see it is -1. So R mean is -1. So you can find the corresponding theta values. So you can say 1 minus 2 sine theta for the R max. This will be 3. And then when you attempt to solve here, what you obtain is -2 is 2 sine theta. And then when you divide, your sine theta is -1. And then you can now figure out what is going on here. So your theta will just be your arcsine of -1 plus 2 pi k. And then for your R mean, do exactly the same thing. You have your 1 minus 2 sine theta, which is your R, and you equate it to -1. Okay, so let's see. And then what you do here, you transpose, you have -2 sine theta is -2. Then your sine theta becomes -1. Why are we getting the same answer here? So 2 goes that side, 3 minus that, minus 2, okay, yeah. So you can figure out what is going on here.
Supposed to be 1, not -1.
R mean. So R mean is 1. Are you saying R mean is 1?
Like when you divide by -2.
Oh, okay. +1. Thank you. So you have +1, and then theta will just be the arcsine of 1 plus 2 pi k. And you guys have been doing this. You can go and figure out what is going on. So that's it. Does this answer the question? So one thing I can say to you is, because I'm also one of those people who do the sketches very fast. So if I was writing the exam on Monday, I would look the sketch again and again. So be careful of your sketch. So do not look at your sketch once. I had to look at my sketch twice to see that, look, something is wrong. I mixed up things here. But yeah, any questions this should answer, you can take it from there. General solutions, easy things.
How would you approach drawing the polar graph? What?
So essentially use the sketch which you have. Let's quickly see, because so let's go here. Sweet. So one thing I would need to first understand hyposymmetry Makes sense. So how in class were you thought this? Because there's maybe program just you do exactly what they were doing. Did they confine how you can draw these for the approach?
Yeah, they say we'll have to ignore the negatives. I mean, where R is negative.
And take the absolute value. Are you still there?
Ash, I couldn't get your question, sir. You were cutting.
Yeah, so I'm saying, they're saying where you see the negative R value, you should take the positive value and do what?
The only thing that they told us, if I'm correct, like we only draw the section where the R is positive, but we don't include where R is negative on the polar curve.
Yeah. So here's what I can do. I can have a look at how you guys draw your polar curves. But an easy way which you can, that's why I'm running away from easy ways. So one way, or when you start drawing your polar curves, the first thing you should be able to know is where is your curve going to lie to? Is it on the horizontal axis? Is it on the left, on the right? Or is it up or down on the vertical axis? So when you have signed, your curve will be on the horizontal, not horizontal, vertical axis. So it is either it's going to be up there or down there, but it is apparent why it is facing down because you have a negative there. So if this was cos, where you see sign there was cos, the graph of yours, which looks like this essentially, if it was cos, it was going to tilt in this direction. But this is not how this one looks. So what I can do is I do not want to do those typical ways where you can sketch this graph without even doing points. So I'll look at how they expect you to sketch it. And what I can do is when I get time, hopefully tonight I can write a note for you. Because I really do not want you to do something which would give you the graph, but now the question would be the lecturer questioning where are you getting what you are doing, because I was expecting you to do this way. Okay, so if there's no other questions, let's call it a day and we can chat on the group chat. So I'll send this and then I'll also send the link to the video recording. So I hope the session was useful and it cleared some of the misconceptions or confusion which you had. So I'll drop a link on the WhatsApp group and please guys rate me. If you feel like the service I provided here, it was a 1-star rated, please give me 1 star on the link which I'm gonna share. If you feel like it is 2-star, please go there and then put 2 stars. Your 1 minute really means a lot. Okay, so we have a hand which has been raised. If you have a question. Okay, no problem. So please make sure your 1 minute means a lot. So we spent how many hours? I think we are over 3 hours. So from your side, all what I'm asking for is 1 minute. I'll send the link, you go there. If you feel like this was 1 star, give me 1 star next time. I'll make sure I do justice. So I will communicate in the group about a physics session. When are you writing?
Friday.
When are you writing?
Friday.
Friday. Okay, cool. There's some still space. So we'll talk about a possible physics session and hopefully a chemistry too. But please make sure you check the link and then give me those 1 stars, 2 stars, 3 stars, 4 stars, 5 stars. If you feel like I deserve 15 stars, call Google and tell them we need to give him 15 stars. So cheers, I'll share this note in the group, so do not worry. And I'll share the recording. So if you feel like I deserve 15 stars. We need to call Google and say, look, we need 15 stars here. I want to rate this person. They're really doing a good job. Otherwise, take care and enjoy. Good people. We'll talk. Cheers.
Danko.
Thank you.
You, good.